This video is a segment from our second episode of Crittercism's office hours, and it will review a code tutorial for an Android Wear project. If you'd like to see the office hours in all of its glory, you can find that video here on our YouTube channel. And if you would like to learn more about the demo being discussed here, you can find the link for the full tutorial in the description below. So we hope you enjoy and stay tuned to our YouTube channel for lots more great content coming down the pipeline. Now I want to get into the actual code, where the differences kind of pop a little bit more, and also so you can get your own project up and running. We've got a full open source demo available at this URL. I will show it at the end of the video, and if you're watching this on YouTube later, it will be down in the video description. So give me just a moment here and I'll set up the stuff needed for the demo. Code on the screen, everybody always loves that. Okay, now just one note before I start the demo. So I've got two screens here. I've got a phone screen and a watch screen. I've got the Android device, the phone device here plugged into my computer. So this is a physical device and I'm just screencasting it. Let me see if I can show it. Yes. So I've got my Android device here and it's plugged in to my USB. And if you're looking for a nice development phone for Android, I'm using a Blue phone, BLU. And I got it unlocked on Amazon for 50 or 60 bucks. It's running KitKat, so it has full support for Android Wear. And it's been really solid for having a nice development device actually in my hand, which I know all developers appreciate. So I'll be using this device in the demo. And then back to the screen, I have an Android Wear emulator that we went and set up through Android Studio. And if you need a little bit of help setting up the emulator, you can do that. We've got full links in a tutorial that I'll post at the end of the presentation that points to Google's Docs. And they've got some great ways to set up the emulator and not only get code running in the emulator, but also being able to connect your emulator on your computer to a device that I have holding in my hand. So you need to do some port forwarding and a couple command lines to ADB, but it's not a huge deal, and it takes just a few minutes to get these two devices talking to one another. So this is our setup. It's going to be a little bit different from everybody, or for everybody, and we're going to use Android Studio as our IDE. So the demo that we're going to be showing is based almost 100% on a Google demo, which is this location sampler. And essentially what this app does is grabs the latest GPS location and displays it on the screen. You can start the GPS or stop it, and it'll automatically update every 10 seconds. So you're probably not going to have a whole lot of success if you just bundle this up and throw it in the App Store. But it's a nice, quick demo that we can use to show off the communication between the phone and the watch, and also some, my American Expresses do. So we can at least show off the communication between the two devices, and also use hardware that's only available on the phone. In this case, the GPS, where the Android Wear device has to rely on the phone for this information. Now, if we look at the code, I'll start with the phone side of things in our main activity. If you're an Android developer, this is looking very familiar. We've got our onCreate method. And we're just unpacking the user interface and setting our text views and our buttons. But at the end, we're setting up a Google Client API. And that's calling this method right down here. If you haven't used this before, it's pretty simple and hopefully self-explanatory, but it's connecting to different Google APIs. And this is an asynchronous method. So what we're doing is calling our location services API and our wearable API. And the location services, that's going to connect to the GPS, and the wearable is going to allow you to connect to the watch. And I mentioned this is an asynchronous method because these things take a second or two to initialize. And once they're ready, they're going to have a callback and say, okay, we're ready to connect to the wearable and we're ready to connect to the GPS. So once this is all set up, we create our location request. Say we want to update our location, in our case, every 10 seconds, and get as good of accuracy as we can possibly get from the device. Now, once our GPS is set up, every time the GPS updates, which in our case is going to be every 10 seconds, it's going to call this delegate method, or this callback method, on location changed. So this is just receiving a new location from our GPS and setting it to a class variable. We go in and we update our UI, which is essentially just setting the text views that we saw in our screen back over here. We're just setting the latest latitude, the latest longitude, and the update time every 10 seconds. So we're doing that right here in this method. And before we talk about this next chunk of code, I want to talk about how we set up the Android Wear app. If you're starting from scratch or if you're starting from an existing app, you can add an Android Wear module by right-clicking on the app and opening the module settings. So you can see we already have a Wear module here, but if you were creating a new one, you can just create one through this plus button and then Android Wear module and follow the dialog until you complete it. And then you'll get this new module Wear location installed right in your project. And this is where all the code is hosted. You'll notice it's very similar to a regular phone app. It's got a manifest file, main activity Java class, and also some layout files as well. And this is all solely for the Watch app. So we'll take a quick look at what the layout looks like. I clicked on this rect activity main file. You'll notice there's also a round one as well. And that is the difference between this square user interface and the round one. Those are the two watch faces that Android currently supports. And if you're building a production app, you want to, of course, adjust for both of these. But for example's sake today, and to keep things short, we'll just stick to the square and use this interface. You can see we've got a latitude label, a longitude label, and an updated label. These are just text views that are displaying our latest coordinates that we're receiving from the phone. If you double click them, you can see we've got IDs for each label. And these are essentially the bindings that will tie back into our code. So this isn't rocket science. We just want to show the latest coordinates on our watch app. So our layout is very simple, and we're just going to leave it at that. If we go into the Java class, so our main activity for the watch, you're going to notice we've got another onCreate method. If you're familiar with Android development, this is all going to come very, very easily to you. So it's a very low barrier to entry to add a watch extension or watch app to your existing Android app. We're going to do the same thing as we did in the phone and inflate our view and tie all of our text views to some class variables, and then create the same type of API client that we created from the phone. And in this case, we're not adding the location API, but we are going to add the wearable API. And that's going to allow us to connect to that data layer that allows the device, the watch device, to connect to the phone. So the same thing applies. This is an asynchronous method, and once the wearable API is connected, we're all good to go. Now, if we want to build and run this thing, it's, again, the exact same as you would do it with a phone app. So we'll select our target here, Wear location, and build and run it. Now, if I pull up our emulator, you can see already we've got our device and our app running, and it's showing the latest coordinates that were retrieved from our phone. So every time this location updated toast shows up, you'll notice that our time syncs up, our latitude and our longitude both sync up. So we've covered the user interface on creating these labels. How is the data being thrown at those labels? How is all that being connected together? And for that, we'll go back to our phone. So our main activity in our phone, this is the method we just went over where every time the location changes from the GPS, we run this method. And we create this data map. So all this is, think of it as a dictionary or hash map, but it's got a specific ID associated with it. And in our case, we named it location. This is an arbitrary string that needs to have value for only your application. So it knows which requests that it's supposed to be making, and both sides know where to find the appropriate data. So in our case, we name it location. We grab our data map and we store all of these attributes to the data map, so latitude, longitude, and the last updated time from our phone. We then make a request and store this request as a data item in our data API. And this wearable.data API, that's the layer that we showed earlier in the slides. I'll actually pull it up here for a quick reference. It's this data sync layer right here. So when we say put a data item to our data API, it's just throwing it at this sync layer. And this sync layer will be automatically propagated over to the app the next time it's open, and vice versa. So going back to our code, that's all that we have to do from the phone side to throw this data at our watch. And of course, we need to handle when this data changes from the watch side. And if you followed our iOS and Apple Watch tutorial last week, you know that we had to pull the iPhone every time the watch wanted to get updated data. So we had a timer running every 5 or 10 seconds, pinging the phone and saying, hey, is there new data? Is there new data? And as a developer, that just makes me cringe because it's ugly and it's also a battery drain. We don't like to just be pinging different sources all the time. And one of the great things I enjoyed about working with the Android SDK is that they have automatic listeners for every time the data changes. So anytime the phone stores new data onto that sync layer, we get this callback method on the watch side that says, okay, the data has changed, go ahead and do something with it. So that's exactly what we're doing here in this callback method in the code on the watch side. We pull out the data item. This is the dictionary or the data map that we set in the phone. And we compare it to our unique identifier. So we want to grab only the location data. You might imagine a use case where you're sending different types of data back and forth. Think of them as tiny little databases sitting in the sync layer. You only want to access the proper database. So first we want to make sure that we're only getting the location data so we know exactly what to do with it. We expand the data map and set all of our watch labels, our watch text views, to the latest values in that data map. So it's extremely simple to extract the data out of this sync layer, and even more simple to notice when the data is changed. You probably noticed that we're running a handler, so we want to execute our UI code on the main thread. So we've got this runnable set up and our main thread handler set up as well. This is something you're probably very familiar with if you're an Android developer. Sometimes this onDataChanged might be thrown in a background thread. So we want to make sure we're running on the main thread so the UI updates properly and at the right time. So that's all we're doing here with the handler and the runnable, but the real code is happening right here, where we're just setting our text views to the latest data. And that's really all you need to be able to link the latitude and longitude on the phone directly to the watch device. Just a few lines of code. It's really, really nice and easy to use. And it was really a pleasure working with Android Wear. We were able to get this up and running in no time flat, it seemed. And it opens up a lot of different possibilities of being able to sync the two devices, sync data between the two devices. And that's going to do it for our structured content today. Once again, we've got our open source demo, the one that I just walked through, available on GitHub. And within the README of that file, or of that project, we've got a link to the full written tutorial that will walk through every step and every line of code. So it'll go into much greater detail if you want to learn the ins and outs of how the app worked. It's a great tutorial, and it's linked through that GitHub page and also through the YouTube description below. Also, follow the good folks over at Crittercism. They've got a lot of content out on their blog, keeping trends with keeping track of the latest iPhone, Apple Watch, Android Wear, all of the good stuff that you're itching to know. They're tracking it weekly on their blog. And also their social networks. You can find them pretty easily on Twitter, LinkedIn, Facebook, whichever one suits you the best. One thing that I want to add is if you're looking for dedicated Crittercism support or just want to go ask the Crittercism team some questions, they run a great weekly webinar. It'll actually be tomorrow morning, so every Thursday around 10 a.m. Pacific time. The support team over at Crittercism talks about some of the new features that they're coming out with and runs some demos, and is also there really to just answer any questions that you might have about integrating with the Crittercism product. So go check that out as well if you've got some questions about Crittercism. And hopefully we will see you here in 2 weeks' time where we come out with our next version of Office Hours. So thank you so much for listening, and hopefully we'll see you in 2 weeks.